Alessandro Volta was born in Como, Italy in 1745, to a wealthy noble family. He attended the Como Jesuit school and a local seminary. His teachers tried to persuade him to enter the priesthood, while his family wanted him to study law. But Volta, even at age 14, knew his real interest was physics. Like many scientists of the time, he was especially fascinated by electricity. Volta dropped his formal studies and did not attend university. Nonetheless, by age 18, he was corresponding directly with accomplished scientists and conducting experiments in the laboratory of a family friend. In 1769, he wrote a treatise on the forces of attraction of electric fire, in which he put forward a theory of electric phenomena. In 1774, Volta accepted a post as an instructor at the Como Grammar School and continued his experiments on electricity. In 1775, he devised a perpetual electrophorus that could transfer charge to other objects, and in the next few years he noticed the bubbling of methane in swamps and was able to isolate the gas. Volta was made a professor of physics at the University of Pavia in 1778. Volta's early work had already made him a well-known scientist, but his greatest contribution to science was the voltaic pile, which he invented as part of a scientific dispute with Luigi Galvani. In 1780, Galvani, an Italian physician and anatomist, was experimenting with dissected frogs' legs and their attached spinal cords, mounted on iron or brass hooks. In most of his experiments, the frog leg could be made to twitch when touched with a probe made of another metal. The frog legs would also jump when hanging on a metal fence in a lightning storm. These observations convinced Galvani that he had found a new form of electricity, which was being generated by the frog's muscles. He called the phenomenon animal electricity. Volta, though initially galvanized by this work, argued that the frog's muscles were simply reacting to the electricity, not producing it. He set out to prove Galvani wrong, and sparked a controversy that divided the Italian scientific community. Volta realized that the crucial feature of Galvani's experiments was the two dissimilar metals, the iron or brass hook and the probe of some other metal. The metals were generating the current, not the frog parts. Instruments available at the time could not detect weak currents, so Volta, always a dedicated experimentalist, often tested various combinations of metals by placing them on his tongue. The saliva in his mouth, like the frog's tissue, conducted electricity, resulting in an unpleasant bitter sensation. To show conclusively that the generation of an electric current did not require any animal parts, Volta put together a rather messy stack of alternating zinc and silver discs, separated by brine-soaked cloth. He built the pile, which consisted of as many as 30 discs, in imitation of the electric organ of the torpedo fish. When a wire was connected to both ends of the pile, a steady current flowed. Volta found that different types of metal could change the amount of current produced, and that he could increase the current by adding discs to the stack. In a letter dated March 20, 1800, addressed to Joseph Banks, president of the Royal Society of London, Volta first reported the electric pile. Volta soon traveled to Paris and demonstrated his invention, which he initially described as an artificial electric organ, emphasizing that animal tissue was not needed to produce the current. The battery was a huge success. Not only did it swing the scientific community to his side in the debate with Galvani, it was immediately recognized as a useful device. In 1800, William Nicholson and Anthony Carlisle used the current generated by a battery to decompose water into hydrogen and oxygen. Sir Humphrey Davy also studied the same chemical effect. In the 1830s, Michael Faraday used a battery in his groundbreaking studies of electromagnetism. Other inventors made improvements on Volta's original design, and soon it was powering telegraphs and doorbells. Napoleon was impressed by the voltaic pile as well, and recommended many honors for Volta, including making him a count in 1810. The invention of the battery brought him great renown, but Volta seems to have preferred a quiet life, and soon gave up most of his research and teaching. He spent his last years living in a country house, where he died on March 5, 1827 at age 82. Since his death, Volta's portrait has appeared on currency and stamps, and his name is immortalized in the unit of electric potential, the volt.